In this section of notes, we're going to continue our study of inference. So previously we talked quite a bit about confidence intervals, which gave us a way to estimate an interval for some parameter of interest. Now we're going to move over to a statistical test for significance. And this is a way for us to compare something that we've observed with something that is claimed to be true. So our first step to conducting a significance test is to come up with our hypotheses. You'll have a null hypothesis and an alternative hypothesis, and you'll use the notation H sub 0 or H sub A respectively for those. Now, your null hypothesis is usually going to be some accepted value or claimed value or value that from in the past you've seen used several times. And then the alternative is maybe you have an inkling about something. So let's look at this example. Let's say that we have someone that claims that they're an 80% free thrower. And in order to prove it to you, they take a whole bunch of shots. And it turns out when they did that, they only made 64% of their shots. So what we want to do is we want to find out, did they just have a bad day and they're really an 80% free thrower? Or did they just give us enough evidence to suggest that maybe they're not really an 80% free thrower? So for your alternative hypothesis, you can adjust appropriately. So in our example, our null hypothesis was that that person was an 80% free thrower. And since they only made 64% of their shots, we would use a less than sign, saying that they're really maybe less than an 80% free thrower. Depending on the scenario, you might use a greater than sign or a not equal to sign. If you use a greater than or a less than, that's a one-sided test or a one-tailed test. And if you use a two-sided test, that is when you have the non-equal to sign. A couple of bits of information you need to know about writing a hypothesis. A hypothesis is always a guess before you have looked at any data. So you don't really want to look at data first and then write a hypothesis. Also, your hypotheses are always about a population, never about a sample. So they're going to be written in terms of parameters, not statistics. So you'll use P or mu, not P hat or X bar. So let's look at a little bit about why a significance test works and how it is putting together information to answer your question. So first we'll look at a simulation. You guys have done some simulations in the past. So let's start by simulating what it would look like for someone who is an 80% shooter. So maybe you would make a spinner that has 10 sections, and 8 of those sections you would mark as making it, and 2 you would mark as missing the shot. That would be something where theoretically that should be an 80% shooter. And then you spin the spinner 50 times, and you record how many times they made the shot. And then you put a dot on the dot plot for that. So essentially that's what was done here. There is some chance procedure, probably with technology, where you're making 80% of your shots theoretically, and then you see in a sample how many were made, and you put a dot for each of those. Now, we've repeated that process 400 times. There's 400 dots here, each of them showing the proportion made out of 50 if the person was in fact an 80% shooter. And we see that there's only 3 times out of these 400 trials where we got results like ours or even more extreme. So they made 64% of their shots or even less. So that gives us a probability of how likely that event is to happen. So we saw that this happened about 0.75% of the time. So that's a pretty small value. So when we get results like this, there's 2 things that could have happened. Either the null hypothesis is true, so this person was really an 80% free thrower, and they just had a really bad day. It happens less than 1% of the time they had that bad of a day. Or the other option is that they're not really an 80% free thrower. So what we want to do is kind of weigh these two options and see which one we have evidence for. In this case, we'd see that that's very, very unlikely for the null hypothesis to be true. It was less than 1% of the time. So that might be some evidence that maybe that null hypothesis is not true. Now that percentage that we came up with from the dot plot where it was 0.75%, that is called a p-value. And our p-value tells us the probability of getting results like we did, assuming that our null hypothesis was true. So if you have a very small p-value, so the percentage of that outcome is very, very small, then that provides evidence against the null hypothesis. But if you have a large p-value, then that does not give you evidence against the null hypothesis. Remember, we have some kind of arbitrary cutoff points from the beginning of the course where we said most of the time we're going to say 5% is our cutoff point, but depending on the consequences, sometimes we might change that to 1% or 10%. So in general, we would say something along the lines of, in our example, this happened 0.75% of the time, and that's less than 5%. So that would provide some evidence against the null. When we go to write our conclusions for a significance test, there's really only two things that we can do. We can either reject the null hypothesis or we can fail to reject the null hypothesis. Be aware that failing to reject the null is not the same as accepting the null. So you should never write a conclusion that says that you believe that the null hypothesis is true. And you should never say something like you are accepting the null hypothesis. So kind of just as your little overview here, if you have a small p-value, you're going to reject the null, which means you have convincing evidence to support the alternative. If you have a large p-value, then you're going to fail to reject the null, in which case you do not have evidence supporting the alternative. Now, it turns out that our 5% that we've been working with, or 1% or 10%, but usually 5%, that has a name. It's called a significance level, and we use the Greek letter alpha to represent it. That actually turns out to be the probability that we end up with a very small p-value and reject the null when in fact the null should have been true. We should have failed to reject it. So to add just a little bit to our previous idea here, rather than just saying if the p-value is small or large, specifically we mean if the p-value is less than our alpha value, then we reject the null and we have convincing evidence to support the alternative. If our p-value is greater than or equal to the alpha level or our significance level, then we fail to reject the null and we do not have convincing evidence for the alternative. Now I want to give you just a bit more information here. So you're used to these kind of sentence structures that I've given you in the past. Here are two more in terms of how you're going to end up writing a conclusion for your significance tests. So first you're going to interpret what the p-value means. And when you're interpreting a p-value, you're going to use this structure. You're going to say, assuming that the null hypothesis is true, there is a p-value probability of getting a statistic of whatever, or more or less, or more extreme, purely by chance. Now, the null hypothesis is true. You're going to replace that part of this sentence with your context. And then your p-value, that will be some number. And then your statistic is what you got in your sample. And then whether you choose more, less, or more extreme, that depends on what your alternative hypothesis was in terms of greater than, less than, or not equal to. So if we were to go back to that basketball problem, our p-value sentence would be something along the lines of, assuming that this person was really an 80% free thrower, there is a 0.75% probability of getting a sample statistic of 64% shots made or less purely by chance. Now moving on to the other sentence about the conclusion. Once you've established what your p-value was and whether or not it was greater than or equal to your alpha value, then you'll give your sentence here. So again, for our example with the basketball, again, that was 0.75%. And I guess we can write that as a decimal. So we'll kind of fill in what we have here in our scenario. So we're going to fill in the blank with our p-value and our alpha value. And then depending on whether we said that this was greater than or less than, if it's less than, that's when we reject the null. If it's greater than, that's when we fail to reject the null. And then the fail to reject and do not have convincing evidence, those will go together, and reject and do have convincing evidence, those go together. And then that last blank where you have your alternative, you're filling that in with context. So our sentence in our example would be something like, because the p-value of 0.0075 is less than our alpha value of 0.05, we fail to reject the null. We have convincing evidence that this person is really less than an 80% shooter. Don't forget to try the practice problems for this section before moving on.